Hello, in this video we're going to derive the utility maximizing condition. So utility here is going to be a function of good X and good Y, units of good X and units of good Y. Here is the consumer's budget constraint. M is money income. We've got the price of good X and the price of good Y, and X and Y again are units of good X and good Y. We're going to set up a Lagrangian. Going to maximize the utility function, subject to the constraint. We're going to take three partial derivatives. Partial derivative of the Lagrangian with respect to good X. So we get the following. We've got to take the partial derivative of this function with respect to good X, and then we get minus lambda times the price of good X. Set that equal to 0. Take the partial derivative of the Lagrangian with respect to good Y. So once again, we take the partial derivative of the function, but this time with respect to good Y. And then the remaining part here, we're going to get just minus lambda times the price of good Y, and set that equal to 0. And finally, the partial derivative of the Lagrangian with respect to lambda, we get back the constraint. The partial derivative of this utility function with respect to good X is just a marginal utility of good X, mu subscript X. And the partial derivative of the utility function with respect to good Y is a marginal utility of good Y, mu subscript Y. And I'll just substitute these mu subscript X in for our partial derivative notation. So doing that, partial derivative of the function with respect to good X is now mu subscript X. And moving this lambda times the price of good X over to the right-hand side, we have this. And solving for lambda, get the marginal utility of good X divided by the price of good X. Doing a similar thing for this middle partial derivative. So the partial derivative of the function with respect to good Y is just a marginal utility of good Y. Moving some things around and solving for lambda. So again, from the last slide, we saw that lambda equals the following. Setting lambda equal to lambda, we have the marginal utility of good X divided by the price of good X must equal the marginal utility of good Y divided by the price of good Y if we're going to maximize utility. And then finally, from the third partial derivative, the partial derivative of the Lagrangian with respect to lambda, we get this result just solving it for income. These are the first order conditions for utility maximization. So to maximize utility, 1, the consumer must spend her money so that the marginal utility per dollar is equal across both goods. So that's this condition right here. And the consumer's choice basket is on the budget line, satisfies the budget line equation. Okay, that's it. I hope you found this video helpful.